Hello, welcome to Physics Tutoring Multi-Choice Questions. Another multi-choice question from AQA A-level. If you want to try and answer the question yourself, stop the video now. If you got an answer of 36 kiloohms, give yourself a pat on the back and either go on to my next video, or if you'd like to stay with me and I'll explain how I got that answer, please stay with me. So let's read the question together. A voltmeter has a resistance of 4 kiloohms and reads 1 volt for every scale division. A power supply has an EMF of 20 volts and negligible internal resistance. That's good. We're not going to have to deal with terminal PDs and any potential difference lost inside the cell or the battery. And it's connected across this voltmeter and a resistor in series. The voltmeter reads 2 divisions. So I would always start by drawing a diagram. Some people think it's a waste of time. I always think it's well worthwhile. Here's my power supply, and connected in series with that power supply is my voltmeter and a mysterious unknown resistor. Nice, simple diagram. And then I'm going to add things that I know. The first thing I know is the power supply has an EMF of 20 volts. So I could put myself a little imaginary voltmeter, and I can even put the reading on it. 20 volts across my power supply. They also were told that the voltmeter reads 2 divisions, and it says it's 1 volt for every division. So if the voltmeter is reading 2 divisions, there must be 2 volts dropped across it. We're also told that the voltmeter has a resistance of 4 kiloohms. So let's just write that in there, 4 kiloohms. Okay, so there's the information we've been given in the question. And we can start adding some things in here. Well, the question we're after is, what's the resistance of this resistor? So I can add my question mark ohms to that resistor. Because in series circuits, the potential difference of the power supply is going to be equal to the sum of the potential difference across the components, I know that 20 volts is going to be shared between my voltmeter and my resistor. So if I've got 20 volts in total and 2 volts is across my voltmeter, then I must have 18 volts across my resistor. Now, potential difference is shared between components in proportion to their resistance. So if I call this component 1 and this component 2, I could say potential difference of 1 over potential difference of 2 is going to be equal to the resistance of 1 over the resistance of 2. Rearranging, resistance of 2, in which this case it's my resistor, is going to be the resistance of the voltmeter multiplied by the potential difference across the resistor divided by the potential difference across the voltmeter. Let's put some numbers in. Said R1 is the resistance of my voltmeter, which is 4 kiloohms. Let's just remember that it's kiloohms multiplied by the potential difference across component 2, which was my resistor, divided by the potential difference across component 1, which is my voltmeter, and I'm going to get an answer of 36 kiloohms. 36 kiloohms. I hope you enjoyed watching this. Please watch my next one and leave a comment below. Thank you.